Hey everyone, I'm just jumping in here to say that this video is part 1 of 2. We'll be talking about a lot of the foundational variables and equations that we need for this inventory model. And then in part 2, we'll tie it all together. When I recorded it, it was just a little bit too long, but this content was too good to cut any of it out, so we're doing 2 parts. Without further ado, let's get started. Hello and welcome to this episode of the Industrial Engineering Notebook. Today's topic is the inventory cost equation. There is one big equation that we're going to get to at the end of this video that describes the cost on average for each week. And once we have that equation, in later videos we can work on optimizing that inventory. But the first step is just to understand where the equation's coming from. And there are a lot of little equations that build up to it. So we're going to draw a graph. We're going to walk through those equations step by step. We're going to make lots of connections. It's going to be great. Let's get started. So on the x-axis we have time, and on the y-axis we have our inventory level. So this could be like the number of items on your shelf. Up here is IUL, or the upper inventory limit. Never more than this many widgets on the shelf. Down here we have the lower limit. You may be wondering why ILL is negative. And that's because we allow for some shortage. So the maximum allowed shortage we're going to call Smax, and it's this distance between the axis and the lower limit. So right here we run out of inventory, and then there are orders kind of piling up for inventory that we don't have, and then we'll start producing them, filling the orders, and then eventually we can start putting stuff back on the shelf. The slope of the line right here, we're going to call lowercase d. This is the demand rate. How many widgets per week or per month that are being pulled from the shelf, or per hour or per minute, whatever the time unit is. And then we hit our lower limit, and we got to start producing or supplying. So the slope of this line here is the production rate minus the demand rate. We subtract the demand rate because even though during this time we're producing, the customer is still demanding widget throughout this time as well. So the slope of this line is P minus D. We're going to call this time right here T01. It's the first time that the inventory level hits 0. And this time right here we're going to call TLL because that's the time that the inventory level hits the lower limit. And this time right here T02 because it's the second time that the inventory level is at 0. And we're going to call this time right here TUL because this is the time that we return to the upper limit. There are some variables that are in play here but are not on this graph. We have R, which is the ordering fee. We have Q, which is the order quantity. So during this time we're producing all the way up to here, to this time. And if you count up all the widgets that you produced during this time, that would be Q, the order quantity, however much we ordered. We have C, which is the widget cost. What is the price to produce one of the widgets on our shelf? We have I, which is the warehouse tax. This is going to be a percentage that the warehouse is going to charge us for storing our widgets there. We have FS, which is our fixed shortage costs. This cost does not change over time. We have VS, which is our variable shortage cost. This cost does change with time. And finally, we have TC, which is going to be our total inventory cost per unit time. So each week or each month, how much are we actually paying to run this inventory? The rates we're talking about in this video are number of widgets per unit time. So 5 widgets per week or 5 widgets per whatever. Sometimes we're going to be looking for the time. So we're going to need to divide the number of widgets by our rate. And sometimes we're going to be looking for the number of widgets. So we multiply the rate by our unit time. All right, now let's talk times. T01 is a time, which means we need to do number of widgets divided by rate. At this time, how many widgets have been pulled? IUL widgets, divided by our rate, which is D. Easy. Next, we want to know the difference between these two times. Number of widgets, Smax, divided by our rate, which is still D. Next, we want to know the time between hitting the lower limit and getting back up to 0. Number of widgets is Smax, divided by our rate, which is now P minus D. Next, we want to know the difference between hitting the upper limit and when we were at 0 for the second time. The number of widgets is going to be IUL, and the rate is P minus D. Next, we just want to know this time. How long did this full cycle take? Well, over this whole time, total, we pulled Q widgets. Remember, that's our order quantity. And we pulled those widgets at the demand rate D throughout this whole time. So the time that we return to the upper limit is Q divided by D. And if we want to know the time between both limits, we just need to add up this time plus this time, both of which we've already calculated. Or there's another way to calculate that time. We've talked about how Q, the order quantity, is both the number of widgets that are demanded throughout all this time, and it's also the number of widgets that are produced just during this time, because supply needs to equal demand at the end of the day. So if we want to calculate this time here, the number of widgets would be Q divided by our rate. The rate at which we're producing is just P. And you may not notice this right away, but we can start to eliminate IUL. We want to replace it with S max, because there are a lot of variables, and if we can take one out, then it will certainly help. So here are the two ways that we could write the time between the two limits. We'll simplify a little bit over here and set them equal to each other. And then if you solve for IUL, which isn't hard, it's just a little bit of algebra, you get Q times the quantity of 1 minus D over P minus S max. All right, enough about times for now. Let's start calculating some costs. If you found this video helpful, go ahead and hit the like button. If you want to see more videos like this, you can tell me that by hitting the subscribe button. Any questions you have, feel free to put them in the comments.